Okay, so today we'll see how to create a simple static linear finite element analysis simulation using Creo parametric or Creo Simulate. So let's go ahead and get started. So I'll open the file. Okay. All right. So this is my this is a plate, and the dimensions are 10 wide by 20 long, and it's half-inch thick. So we'll apply a tension load of say 500 pounds this way, and then constrain it at this end. In any finite element analysis simulation, well, even before that, let's do something. So file, go under model properties. So here, if you see anything else, if you see, go ahead and change it. Generally, it is set to default, but if you see it, go ahead and change it to inch pound second and say close and say close. Okay. So that sets the default dimensions to inch pound second system instead of the native or the default Creo parametric system. Right. Then to start the finite element analysis for part of the software, which is called Creo Simulate, we go Applications, Simulate, and this already has these loads and constraints. Let me go ahead and delete it so we can start fresh. Delete that. We'll delete these loads as well, and I'll also delete that. Okay, so in any finite element analysis simulation, these are the things we need to do, not just in Creo Simulate, but anything, Nastran, SolidWorks, COMSOL, or any other FEA software. We apply loads, we apply constraints, we apply materials, and then we choose what kind of analysis we want to run. So these are, and then we also generate mesh, but in our case, in this case, when you run the analysis, the mesh is automatically generated. But in some software, there is another step where you generate the mesh. Okay, so let's apply the forces. To apply the force, we need to select the surface. So I'm selecting this surface, and the way I rotate this part is by pressing down, holding down the middle mouse button, and I can rotate it. I'm applying loads on this surface. I want to pull it in this direction, which would be a negative y direction. If it's not very clear here, you can also see it here. So I'm going to apply negative 500 pounds. Okay. And I say OK. It shows these vectors that represent the load. Next thing we do is apply constraints. So loads and then constraints, which is also called displacement. So displacement. So here we select this surface. That is the surface I want to completely hold. I'm holding at one end and pulling the other end. So I'm holding that end, and by default, these are all fixed. So I don't need to do anything. I'll simply say OK. And for some reason, if anything, one of these other ones are selected, go back and click on these and say OK. Okay. The next thing is selecting materials. So when you click on the materials, this opens up. Go to legacy materials, select 6061 or any other material. This is already there in my selection from the previous analysis. I'll say OK and OK. We have only selected the material so far. We have not applied it to the part. So to apply it, click on material assignment, and I select this one. Okay. So the material. So as soon as you apply material, you should see something like this. If you don't see this, then the material has not been assigned. So the last step is selecting the analysis. So I've run this before. I'm going to delete this, create new analysis. New static. So I'm going to say plate underscore static. While naming the analysis, you shouldn't have any spaces between words. You cannot have a hyphen. Underscores are allowed, and you're not allowed to start with a number. It cannot be like 111 plate. Here, go ahead and select multipass. You can go up to 9, so max it out at 9. And then for a simple part, do it. If you have a complex part with lots of surfaces and features, then keep it to 6. Here, convergence criteria will make it 5 and say OK. Here, we're going to, in configure run settings, click that. This is the directory in which it's going to save all the files. For memory, the default number shows as 512, but you can max it up to 50% of your RAM. I have 16 gigs of RAM, so I've made this 8 gigs. If you're not sure how much RAM you have, just leave it at 512, which is the default. I'm assuming you should at least have that much RAM. So I'll say OK, and then we're ready to run the analysis. Yes, and then click on this, and it shows as the analysis is progressing. It has already run the analysis, and here you can see the stresses and everything, and the convergence criteria and so on. I won't worry about these for now. Maybe I'll make another video where I go about explaining all of these. But for now, let's jump into looking at the results. Results, stresses. Let's look at the YY stress. And then I also want to see the element edges. All right, so that's our to zoom in, zoom out. I'm using the middle mouse button, scrolling it to zoom in, zoom out. Let me do this so you can see the stresses. Okay, this is called the legend, and here it tells you based on the color you can see what stresses you have. If you want to look at it more closely, click on this dynamic query, and as you click on different areas, so it shows you the stresses at that point. Okay, these higher stresses, 218, 204, these are at these extremes, and these are singular areas, so you would always have this unreasonably high stresses here. If you just do load over area, you should get something like 100, and that's what we see here. And always near the constraints, you see these higher stresses. Generally, for practical purposes, you can ignore it. And look at these stresses in these areas. And you can also clear all of these tags. So all of them are cleared. If you want to know the maximum stress, you can say maximum stress is there, minimum stress, right? And then again, to know stresses at a particular point, you can zoom in and then click at these locations at the stresses, and that's how you run a linear static analysis.